I'm CK. Tonight we've got a module from Molten Modular via Befaco. It is their Motion MTR, which I'm going to assume the MTR stands for monitor, because what it does is it monitors and displays CV, and it also provides CV offset, as well as a mixer, and it's got some fancy LEDs and other fun things on it. So we'll put it together and see how it works. Hope you enjoy the video. So let's see what we got in the bag. Again, it's packed by Befaco, but it's from Molten Modular in partnership with Befaco, and I don't know what that really means, but they're working together, which is good. There's the assembly guide and the bill of materials, QR codes, and is this a sticker? I don't think this is a sticker, it's just a piece of paper. Let's look. Power cable. Let's take this bag out. Here's our Molten Module sticker. Oh, no, that's Nerly's. Befaco gave us more Nerly's, which is always good. It's better than buying them. Though I do personally recommend, particularly if you're in a studio setting, using Nerly's. They're very handy for taking modules in and out very quickly, not having to use a tool. Let's see what the front panel looks like. So we've got Molten Modular, audio, CV attenuation, and CV inversion. I think that probably means that must be a switch. Here's a pot, a pot, a pot, and around here this halo is a bunch of LEDs, I believe, and there are audio, CV atten, CV invert on all three of them. So there's 3 ins, which look like they're maxed at 10 volts, which is dandy. And this is out 1, that's out 2, and that's out 3, and the mix. So I don't know how it mixes. I don't know whether these knobs are for attenuation or whether they're for mixing. We'll figure that out. Pull the circuit board out, and it's a dually. Lots of foam. Shrink wrap, bubble wrap, which I don't particularly care for because it does not recycle. Okay, so it's got some surface mount already done. The LED halo we talked about a minute or two ago is all right here. These are all little surface mount LEDs. They're also square instead of rectangular, which is interesting. And they've got a bunch of capacitors linked to them, not resistors, which is just interesting to me. I don't know where they're getting the current limiting for the LEDs. It might be in this package. I haven't used these square LEDs, so I don't know. On the back, typical, well, obviously if Molten Modular did the design, well, Befaco certainly did the circuit board layout because it's got the iconic curvy circuit board traces all over the place. And we've got one surface mount chip here, one surface mount chip there to put on. And the rest of it is all standard componentry. Looks like a timing crystal goes there. And a programming connector there. And a couple of ICs here. A big old microprocessor goes there, I bet. It doesn't look as... It's packed as tight as all Befaco boards are, which can be a challenge for beginning assemblers, but you get the hang of it. And power connector, of course. So it doesn't look too terribly horrible. Circuit board is, of course, all through-hole plated. So we got some knobs in here. They look cheap. I mean, they'll do the job, but there's nothing special about them. There's the knurlies. Yeah, these are just run-of-the-mill knobs, no set screws, no metal in them. So in here is, okay. In here, I was wondering about that. Because if we look here, let me show you what I'll show you what caught my eye, and then we'll see what the solution is here. Let me take one of these potentiometers out of the bag. Try not to lose this standoff while I'm doing that. So if I put a potentiometer in one of these holes, or in one of the potentiometer positions, being careful not to knock any of the surface mount components loose while I'm doing this. I'll just put it on there for now. And we put the front panel on it. Obviously there's going to be a distance, not quite that much, probably quarter-inch less that. The LEDs are pretty far away from the front panel. So what they have inside this little foam packaging material that I'll try and cut apart without busting anything. So we have these little light pipe assemblies. That. So they will sit on top of the LEDs and transmit the light through the holes on the front, even though I can already tell it may be a bit of a pain to get these through, or I'm doing it wrong and I should be doing it this way. Yeah, I was doing it wrong and I should be doing it that way. Then it goes flush against there and just conducts the light forward into the part, or into the front panel. Put those aside so I don't lose them. Let's look at the rest of the mechanical bits. And put that potentiometer back in there, or else I will lose that and won't know what the heck is going on. Some jacks, the potentiometers, 3 of these 3-position switches, some Befaco panel nuts, which are always very attractive, and standard jacks. Nothing too unusual there. We'll take a look at the rest of the electronics. And of course, my 15th Befaco panel nut wrench. They got to make a check mark saying, please don't send me another one. In here we've got an Atmel microcontroller. That's the ATmega 168PA. Then we've got an MCP 6024, which I just used that a little while ago. I forget what it is, though. My brain is a sieve on part numbers. Op-amp, 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 and op-amp. And again, I think this is some type of... I'm not going to speculate. Sorry. I'll look it up and let you know in a minute. Or I will forget, as I usually do when I say that. And then you'll never know unless you look it up yourself. Whole bunch of resistors, 2 diodes, and as typical with the Befaco board, 2 ferrite beads as inductors to take some noise out of the power. And then here are the 2 surface mount components, and I can't for the life of me read that one right now, so I'll look it up in the interval, I believe. And then in here We've got the power connector, the pin headers to connect the two boards, and a whole bunch of 104 tenth of a microfarad decoupling caps, and some 10 nanofarad caps, and a couple of 3 electrolytics, and something in here which is probably a voltage regulator. I'm going to move the resistors out and make sure I didn't lose the ferrite core when I did that. And here we've got, I don't know whether these are transistors or voltage regulators. No, these are voltage regulators. They're both 78105s. 78105s, both voltage regulators. And something else. I don't recognize this part number. I'll look that up too. Maybe. And we've got 2 of those. So we got 2 5-volt voltage regulators and 2 of these guys. And I don't know what they are. Maybe it'll be in the bill of materials, so we can just look that up. So that, and here is a timing crystal. What is it? It is a 16 megahertz, looks like. And that's it. Not too bad, not too complex, but it will be interesting. So I'll get the soldering iron heated up. I'll take a look at the bill of materials and see what these chips are, and we'll get this thing going. So my memory did not fail me that MCP 6024 is an op amp, and then these 2 surface mount kits are, or parts, are 2 surface mount TL072 op amps. So a whole bunch of op amps on this board. The build guide looks good. It's very detailed. They have a good bill of materials too, so you can you don't need the build guide per se if you just want to go through the bill of materials and track it. I'll follow the build guide since I'm doing this on camera. First I'm going to break off the sprues here. We're the build guide author, and I generally agree on best way to hand solder SMD, even though he does not use external flux. I choose to because it works better for me. Use whatever technique you've developed. If you want to look at some other things to practice surface mount, I've got a number of videos on my channel of practice surface mount soldering kits from various manufacturers, and you may want to buy one of those before, like something like this. This is a little LED kit, a Ferris wheel kit, and it's got like 100 surface mount LEDs on it that you can practice with pretty well. So I'm going to be using my thinnest solder that I feel comfortable hand soldering with, and this is from MG Chemicals. It's 0.025, and it is flux core, so you don't technically need additional flux. I tend to use it, and I'll show you why in a minute here. So what we're going to do, and there's one here and one here, and they're oriented the same way, which is nice. I'm going to put a dollop of solder on the pin 1 pad, on both of them, may as well, even though I'm not going to do both of them at the same time. Now, pin 1 is going to be where the stripe end of the chip goes, kind of like so. I'm going to zoom the camera in a little bit more so you may be able to see what I'm doing better, and move it around aimlessly too. So now And I will probably get my head in the shot in this, because one of the things you want to do is you want to get the legs of the IC right over the pads and relatively even side to side. And then that little dollop of solder I put on there, I'm going to heat up again. And the leg of the chip did not do what I wanted it to do. Heat up that little dollop of solder and the chip leg will sink into it. Like that. And now it's not going anywhere. So you can solder the rest of the legs. Now I'm going to try this without using additional flux right now, just to see how it goes together. And if we need additional flux, I'll show you that too. But what I tend to do is I will put the soldering iron tip between two legs, draw the solder out, and that works pretty well without fouling anything. So that's those 4 legs, and I'm double checking to make sure they have good connection, and they sure seem to. And I'll do... Now we'll do the same thing for this one over here. And we'll do that in we'll replay that in fast motion. And there those all are. So the 2 surface mount op amps are installed. I'll back the camera back off. Now we'll do the resistors. There are 2600K resistors, 26 of them. I'm trying to detangle them over here in the parts bin. It's a lot of, and they're all quarter watt. I'm going to verify that they're 100K just because I can. And if it takes 15 seconds to verify value, it's well worth it. Oh, I was on millivolts, not ohms. That'll be a problem. And that's 102K, which is close enough. And again, because I was holding them on with my finger, it probably was not as accurate as it could have been. So let's see what the numbering convention on this is so far. So sometimes Befaco will put a number in front of the value, like 111, or instead of 11, they'll make it 111 for one of the boards, but it doesn't look like they did it on this one. Looks like we've got resistor 1, might be around somewhere. Looks like 1 through 28 or so is on this board, so we'll start with that. If I could find resistor 1, it would help. There's R5. There's the 2 ferrite cores go there. There's R2. There's R3. So R1 is around here somewhere. Again, Befaco packs so many components so close together. Oh, but we're going to start. So never mind, doesn't matter, because we're starting with R7. So let's do 1 to see how the board feels on taking solder and setting the component legs, how far you have to bend them in from the body. And as typical with a Befaco product, you want to go pretty close, even though since these are quarter watt, not half watt resistors, the body of the resistor is a little smaller. So you don't have to bend the legs all the way up to the body. So, and we'll give this a little solder, see how it goes. Solders very well. Again, Befaco makes very, even though the boards are packed way, way tight and the traces wander hither and yon like streams, they do make good boards, or have a good board manufacturing partner. So that went together fine, and you can see because it's through-hole plated, the solder has wept through the hole, giving you a very good connection. That's why if you're looking and you see non-through-hole plated boards, they may be a little more challenging to ensure you get good connections. So if the person you're working with uses through-hole plated, you're in good hands. Now I'm going to go do all the rest of these resistors, and not much more to say about it, so I'll speed up the playback. So we'll just see them all dash onto the board, and I'm going to be listening to WQXR 105.9 FM out of New York on their iPad app, the best classical music station in the world, in my opinion. And we'll start with Symphony No. 3 in C minor, Opus 78, by Louis Spohr, by the German Radio Philharmonic with Harold Griffiths conducting. That's all the resistors for this kit. Two things. I ended up with one extra 100K resistor, and then one thing you want to be careful of is, so R28 and R36, which are here and here, they basically share a hole back here. There are two solder points, and they are connected, and you're going to put one solder glob on both of them. But they're different values. R28 is 100K, and R36 is 1K, and comes much later in the list. So I looked ahead, and I put R28 and R36 in at the same time. I, of course, also left myself a note here that I already did R36, so I wouldn't forget later on and get perplexed by the count wasn't coming out right. Let's see, there's a bunch of, yeah, he mentions it here. Also, there are a couple places where resistors have connecting pads. Be careful not to block the other hole while soldering, or do not solder until both resistors are in place. My suggestion is do not solder until both resistors are in place, because since the two solder rings are immediately, they're connected, solder is very likely to flow across both. Now we'll do the diodes. Now we'll get into the power protection and conditioning that Befaco likes to do. And they do more of this than I believe that, in my experience, most board manufacturers do. They put a lot of power protection on their boards. So here's diode symbol there, with easy to see stripe, so you know where the stripe on the diode itself needs to go. I'm going to put these on first, and then we'll do the next step, because the next step's just a little, you might not have done it before. So I want to focus on that and get these soldered down and out of the way. Now for the ferrite cores, and there are two of them, little iron ferrite cores. Their inductors get a little noise out of the power signal, if there is any. So what we're going to do, and they go here where it says F1 and F2. and they're Fs because they're ferrite. And usually, because they're power conditioning, they're going to go right near the power connector. So you take the ferrite bead and a resistor lead that we saved from all the resistors, and put it through, bend. Same for the other one. Find a likely resistor lead. This one's got a little hook on the end that I'll cut off and drop on the floor because I vacuum the workshop floor after every kit to get rid of all the stray component leads and solder that I fling over on the ground and that kind of stuff. Just keeps the place spiffy. Now we're going to put all the sockets on the boards. Now you can put sockets on a number of different ways. I'll show you two. The first one that I generally do, I just rest the socket on my ring finger, do one pin, let it cool, take a look at it, it's all flat. So that's one way to do it, and I'm making sure the notches in the socket match up with the notches on the board. Another way to do it is grab a set of locking tweezers, grip it like that, and it's not going anywhere either. Same thing, do one leg, take the tweezers off, take a look, make sure it's all flat, and it is. And of course there is another way. I mean, there's lots of ways, but another way to do it is just grab some painter's tape, and I always have a roll of painter's tape hanging on the wall next to me, and you can tape the socket down like that. Same thing, do one leg first, take the tape off, make sure the socket is flat, and it is not. It's a little up. So I will press on it with my index finger, reheat that solder, and it clicked down flat on the board. So that's 3 different ways of putting sockets on the board. Now we'll just go ahead and put the rest of them on. And I'll do all the pins too, so we'll have a little more speed up time. So next we're going to do the capacitors, the disc caps, and first we're going to do all the 104s, and there's nothing really much to say about these. Oh yeah, they've got two 104s right in the whole power protection area. God, Befaco really does like to make sure that by the time the power has come in through the power header here, it's gone through an inductor, it's gone through a diode, it's gone through a smoothing or decoupling cap, and a resistor. They're just being really certain you have clean power when you're producing music, which is a good idea. But again, not much more to talk about on this, so we'll go back into fast playback. And now we'll do the voltage regulators, and we've got our 4040s, LM4040s, and we've got two L78 78 LO5s. So we'll do the 4040 first. They go into reg 1. Reg 1, there it is. And flat spot to flat spot, of course. Now we'll put the crystal on the board. Right over here. Crystals are not polarized, they can go in either way. Now we're going to do the electrolytics, and then we'll solder this all up. And there's only 4 of them. Let's see, 1, 2, 3, 4, and they all cluster up here. And these are polarized, and the board is clearly marked with where the positive and negative terminals go, so you shouldn't have any problem with that. Now it's time to put the pin headers on, and we're going to put the male pin headers on this board, the one with the... I always get confused about what to call them. I wish we had a common convention. I'm going to call it the logic board because it's where the microcontroller is. So I'm just going to put them in and just roughly and solder one pin and then make sure they're all straight. The author of the build guide is one of those folks who likes to put the two boards together with the pin headers mated to ensure alignment. That's a fine thing to do. I don't choose to do it because it's just not something I like to do it the way I like to do it. That's why. Oh, and this is the ISP, the programming pin header that I'm not putting on, and they didn't include the connector for that because I'm not going to be programming this microcontroller. Do the same thing on the other board. Now, with one pin soldered on each of the bottom ones, I will give it a little test fit, make sure everything's lining up and everything's looking good. So I can go ahead and put the rest of the pins in the soldered mode. Here's the pin headers. Now, put the power connector on, and it is a keyed power connector. So there's a mark here for where the notch in the connector is, and as I like to do, I just double check that the notch and the red stripe mark on the board all correspond to each other, and they do. Use this little piece of solder. Now we'll put all the ICs on. And that's the chips. And now we're going to do all the front panel controls. And we'll do them in the order that everyone, or that the build guide suggests. Get this out of the way. Switches first. See how tight, how snugly these fit. They stay in pretty well, so I don't have to worry about much there. I'm going to put the front panel on it just to make sure they're roughly aligned, and they are. Now we'll put the pots in. I'm going to straighten these legs out just a hair, because when I did this at the very beginning of the video, it felt a little close. Now put in our jacks. Try not to knock the pots off while I'm putting the jacks in. Ground pins are a little offset, and they're shared. So these two sockets share a ground pin hole, just like these do. There's all that. So what I'm going to do right now is put the front panel on. Like so. Make sure everything fits through well. Just double checking the switch operation. And put those all in the middle and all the way down. That looks good. Now what I like to do, everybody has their own technique. Oh, I'm sorry, I forgot one thing. Got to put the light pipes in. It looks good. You can see the light pipes are sitting all on top of the LEDs on the board. Now what I like to do, everybody's got their own technique for this, but I will solder one jack pin down here. Make sure it's flat on the board, and it is. And go up here to this pot and solder one of the support legs for it. So we've got one leg here soldered and one leg on this one soldered. So I will put a panel nut on the ones where I've soldered a leg. We've got two different size panel nuts for the jacks and the pots. So snug that down, snug this one down, everything's held in place. Now interestingly, the switches, as you can see, it's about 1/8 of an inch, 3 millimeters gap there. So the question is, do I want to push them up against? Because I can do two things. I can do this and have the switch head come really far out, and then the pins are kind of short, or I can have it the other way with the switch lower and the pins are, the switch is flat on the board. I think I'm going to go with flat on the board because I can switch these switches pretty easily. I get enough purchase on them to do what I want to do. If not, I can always change that later, desolder, resolder it. But for right now, since everything is all held together, I'm going to solder all the pots and jacks. I could have put these standoffs on before we put the panels together, but since they're right at the edge, it's a piece of cake. There that goes. Let me double check all these switches work well. We do. Pots turn well. I'm going to put the rest of the panel nuts on now. Red for output, black for input. And that's that. So now we'll put the two boards together for the final time. Now we'll put the knobs on. Make sure they're all counterclockwise. These are pretty stiff. No, they're not bad. Try and get the index marks to somewhat line up with each other. And put the power connector on. Double checking as always that the red stripe is going in the right direction. And there we go. There's the front. There's the side. Other side. The back. Top. And the bottom. Now we'll put it in the rack and see how it does. Alright, so we're in the rack. Let's turn it on. And we got two little zippers of LEDs running up. I've got everything in audio mode right now. And the first thing, when you're all the way to the left, you'll see one dot, and then when you turn it up, it'll be like a VU meter. So what I'm going to do first, just for fun, is we'll do CV attenuation first, and I'm going to put the output of the LFO in here, and I'm in the wrong spot. Put the LFO in there, and the LFO is going pretty fast, but as you can see right there, LFO is going back and forth and back and forth and back and forth. That's with it attenuated somewhat. Let's open it all the way up. There it goes all the way back and forth and back and forth and back and forth. Now we'll put some audio in there. Where's my... And as you can see, as it's coming in from there. We'll attenuate it now. Now I'm going to take the LFO and put it in number 2. And put that on CV. And put that in to the frequency modulation on the VCA. The VCO. Now we can attenuate the LFO. So you can almost, the LFO is almost doing nothing. Turn it down, rate down a little bit. So we can easily change the LFO voltage in. Now the LFO is completely out again. Now we can invert this. So that's just reversing it. It's not really noticeable that way, but now if we take the 1 and 2 out, then everything is summed into 3, which will kind of sound weird. But as you can see, now we're not getting any action on the frequency modulation. But if I put that back in, it'll cut out 3. Oh no, it doesn't cut out 3. That's interesting. So I'm going to invert And take this all the way down. Now I don't have another VCO out here, unfortunately, so I can't sum in two signals, but you can obviously, again, if you have 1 and 2 unplugged, everything is summed into 3, and if I had another VCO, you could see that it's a mixer. So that's what it does. Pretty straightforward, not a very complicated output. The assembly was more complicated than the actual implementation. But as you can see, you got a good VU style meter for the signals you're putting through here. Let me go back to see what the LFO sounds like. You can hear the LFO. Invert it. And back to the VCA. Go back to, where's my gate? I'll put my gate back in here. And we've still got the LFO going, and let me plug that back into frequency. Have just a little or a lot. So it is one place to be able to change your signals. Now see, in audio it's making the LFO signal even more interesting. So that's it. 3 attenuators or inverters if you want, either for audio signals or CV, normal or attenuated. Plug into all 2 or 3 of them, and take the outputs out there, and it'll sum to 3 and go out. And it's nice to be able to actually see this. Seeing the actual voltage values as a little LED type VU meter is pretty neat. And that's what it does. Not a straightforward build. There's a lot of parts to it, but not hard except for the 2 surface mount op amps, and that's what it does. A nice first unit from Molten Modular, courtesy of Befaco, and it's going to be very attractive in your rig if nothing else, and nice to have a visual representation of the voltages or values you're seeing. And I hope you enjoyed the video.